Warning: the following procedure utilizes main voltage and the final product is a potential fire hazard. Any attempts to recreate the product is at your own risk. Hi, today we'll be making a stirring heating mantle, so let's get to it. First we need a flask the size we want a mantle, and we need a pot to fit the flask. Furthermore, we need a PID controller. This one has an internal relay, but yours may be the digital output for switching solid state relays. Then we have a thermocouple, some resistance heating wire, an ordinary steel wire, a 12-volt supply which I got from a wall wart. I have a power cable, a small DC fan, some heat resistant wire, neodymium magnets. I have a threaded rod with nuts and washers, a sheet of fiberglass, a base plate, and maybe a potentiometer. We start by measuring our base plate, checking how everything fits, and by rough measuring we get our dimensions. Then, through the magic of video editing, we are left with a ready cut base plate. Using the remaining pieces, we measure up an enclosure for the PID controller and the power supply. Now we start working on the heating element. Start by wrapping fiberglass around the flask, making sure to straighten out any nooks or crannies. Then with a pair of scissors, cut a piece big enough to cover half the flask. Save the scraps, these will be used later. And now, once more, in the complete violation of energy conservation, video editing will duplicate this piece of fiberglass. Then we cut out another piece, this one at least 3 times the diameter of the flask. This piece will be used to wrap around the heating element and is the piece in contact with the flask and the final product. Now we measure up our heating wire. The exact length is determined by the resistance per meter of the wire and the desired wattage by the formula power equals voltage squared over resistance. Then we take some kind of smooth rod with a diameter of 4 to 5 millimeters and tape the wire onto one end. Then we start the laborious job of winding the wire onto the rod, making sure that each winding is tight along the way. But you guys are in luck and can watch this with 32 times the original speed, and under such circumstances the windings are done in no time at all. Finally, we remove the tape and start stretching the wire such that no 2 loops are touching, as this will cause shorts and hot spots in the wire. When we are pleased with the spacing and final length, it is time to pull the rod from the wire. We just do a final bit of stretching, and as we see shortly, the rod comes straight out from the wire, no problems at all. And then you have your completed heating wire. Next, we take one of the smaller pieces of fiberglass and start sewing the heating wire in a spiral pattern, starting at the center and working outwards. Using a pair of scissors, I poke holes first so that the wire coils get through easily. This takes a bit of time, but it doesn't need to be pretty. Just make sure consecutive spirals don't touch, and you should be fine. With the spiral complete, we take our heat-resistant cables and strip off the ends, giving us a good amount of exposed wires to work with. Now we straighten out the ends of the heating wires a bit and twist the wires tightly around the heat-resistant cables, making sure that there's good electrical connections. We do the same to the other end, making sure that both wires come out the same side of the fiberglass sheet. This becomes important later on when the fiberglass and the heating element is stuffed into the pot. Now with the final piece of fiberglass, we cover up the bottom of the element, feeding the cables through the fiberglass, giving some insulation for the cables. Now, in order to support our heating element, we're going to take a piece of steel wire and wrap it around the flask. We use a bit of tape just to hold the wire in place while we shape the wire to the flask, making sure that everything is aligned. And then we take another bit of tape, we use that later to snip off the excess, and we use our pliers to twist the wires in place. After a bit of shaping, the wires pretty much circular, and we just trim off the excess and we're done with the support. Here I'm just approximating the center of the pot with a compass. From the center, I'm going to draw a circle almost to the edge, giving just enough room for the bolts and washers. Now, without changing the span of the compass, I notch out every step along the circle. These have an angle of 60 degrees, so every other should give me my desired 120. Finding our base plate, we're going to do the same by circling out and notching the steps. The span is still the same, so when the holes are drilled, they will all line up, hopefully. Then with a pencil we mark out every hole that we're going to drill, and we do the same for the pot. Then with a 3mm bit we pre-drill the holes, making sure we don't go through. In the pot it doesn't matter, so we go straight through anyways. Next we need to make sure that our drill bit isn't going through the base plate. To do this we measure the drill bit along the side and knock it off with a bit of tape. Then we drill the holes down to our tape mark, and furthermore we drill the holes in the pot. If your pot is aluminium, you can cut off the excess from the drilling with an X-Acto knife. Then we take a threaded rod and secure it in a vise. We measure 6 centimeters, and then we cut it off with a hacksaw. We will need 3 of these in total for the feet of a mantle. Now we are drilling a hole for a thermocouple. First drilling a guide hole before swapping the bit for a bit matching the diameter of the thermocouple. I start at an angle, but then align it to the bottom of the pot. We then take the thermocouple and secure it in place, so that it is suspended just above the bottom of the pot. Now we position the fan in between the leg holes and drill one of the corners. We secure the fan in position with a screw and drill the hole opposite. We then fasten it with screws and drill the remaining holes. We then take our legs and sink them into the holes with a nut and washer on top. Taking our pot, we then fit it over the legs and tighten it in place with another washer and nut. Now we use the fiberglass scraps from earlier to stuff the bottom of a pot, and unlike me you should consider wearing gloves when handling fiberglass. Next we drill 2 holes in the side of the pan for the leads from our heating element. Once more we find our flask and center it under the largest fiberglass sheet. We then wrap it tight and try our best to rub away any folds. When we are somewhat pleased with our results, we take our heating element and we fasten it with a support ring, making sure that it's not in contact with the coils inside the element. After this was done, the whole assembly was stuffed into the pot and the flask was removed. The leads from the element was pulled out from the holes in the back, and a short extension was soldered to the leads. Now this is a lot easier if you have a pair of helping hands, and pre-tinning your wires always makes everything a lot easier. If you're new to soldering, always make sure the solder flows. If it doesn't, your workpiece is not warm enough. Then, with a piece of Kapton tape, we insulate the exposed wires. This is then followed by us feeling the wires through to the front. As you can see, I found a piece of aluminum in which I cut a square hole for the controller. The wiring of the controller is often labelled on the side, and we start by connecting the thermocouple, and making sure we tighten the connectors. Now, with both connectors in place, we take the leads from the heating element and strip off the ends. Next, we find our power cable, we strip off the ends and give them a good twist. We now twist together the neutral from the heating elements with the neutral of the power cable. We then connect the live cable from the heating element to one of the relay connectors. Then, with the 2 neutral wires we twisted together earlier, we connect them directly to the PID controller mains input neutral. We then need a small lead that can go from our mains live to the other relay connector. I just used a small piece of wire that I stripped off the ends and twisted together with the power cables live. This was then connected to the PID controller live, and the other end to the relay connection, making sure that all the screws are tight. Then we twist the ground cable around the cable going to the thermocouple, and we secure it in place with a bit of tape. Now it's time to connect the 12-volt supply for our fan. The two magnets in the intro have been glued to the fan with epoxy in the usual stirring configuration, and here all you see is me soldering a few leads to the supply, and the idea is to simply expose a bit of the mains live and neutral and simply solder the supply in parallel. We then put everything into the fixture and secure it in place. To avoid any shorts, the supply was stuffed into a plastic bag and the 12-volt leads fed through a hole in the corner. Everything was then cramped into the bag, and since I didn't want to shorten the cable of the thermocouple, this was coiled up and stuffed in as well. Finally, we connect the fan. Here would also be the place to connect the potentiometer in series in order for it to act as a rheostat. The pot was then put back in place and we are ready to do our first test. With everything in place, we connect the power cable, and as we can see, the coils turn on and there doesn't seem to be any problems other than a few hot spots. Next, we have a dry test of a magnetic stir, and other than a few improvements like a proper motor controller that would actually utilize the tachyometer in the fan, and the fact that I should have used higher grade magnets, we now have a fully fledged heating mantle. I hope you enjoy, and I'll see you next time.